now that we know how to come up with a composite function, let's talk about the domain of a composite function. So let's let f and g be functions. The domain of the composite function, f of g of x, is the set of all x in the domain of g such that g of x is in the domain of f. Now the important thing to remember here is that the domain of the composite function will be a subset of the domain of g. Okay? Now there's a couple steps that we're going to follow when we find the domain of the composite function. And let's talk about those real quick. The first step will always be to find the domain of g. Again, once we find the domain of g, okay, the domain of the composite will be a subset of that domain. Next, we will exclude from the domain of g all values of x for which g of x is not in the domain of f. I think it's best shown with an example, so let's take a look at an example. All right, so let's find the domain of f of g given that f of x is equal to x over x minus 3 and g of x is equal to 1 over x plus 5. Now again, the first thing that we always want to do is find the domain of g. Okay? Well, g is a rational function, 1 over x plus 5 in this case. The domain of any rational function is all real numbers except those values of x for which the denominator is equal to 0. In this case, the denominator will be 0 when x is negative 5. So the domain of g is all real numbers except negative 5. So negative infinity to negative 5, open parenthesis on the negative 5, indicating that negative 5 is not in the domain, union negative 5 to infinity. Now the domain of f composed of g will be a subset of this domain. Now we might have to pull out a couple points out of that domain. All right, well let's look at f composed of g of x. Let's take a look at what that function looks like. F of g of x is equal to 1 over x plus 5. Okay, we're taking the function g, substituting into the value of x into the function f. So we get 1 over x plus 5 divided by 1 over x plus 5 minus 3. Now we already said that negative 5 was not in the domain of f of g. Okay, so now let's take a look. Notice that we have a denominator down here. The denominator cannot be 0, so let's figure out when does g of x minus 3 equal 0? Or when does 1 over x plus 5 minus 3 equal 0? If we can find that x value, we'll have to pull that x value out of the domain of g. And that will give us our final domain. So let's do that. Let's figure out when does 1 over x plus 5 minus 3, when does that equal to 0? So let's get a clean sheet of paper and then we can finish this problem. So we can solve for x by first adding 3 to both sides. Then we can multiply both sides by x plus 5. The x plus 5 factors cancel on the left, leaving us with 1 equals 3x plus 15. Subtract 15 from both sides. And finally, divide both sides by 3. So we get negative 14 thirds is equal to x. Now let's figure out what that means. If we go back to the previous page, we just found that when x is equal to negative 14 thirds, we get a 0 in the denominator. That means we're going to have to pull out the value of negative 14 thirds out of our original domain of g. Okay? So what that means for us is that the domain of f composed of g is all values of x except negative 5 and negative 14 thirds. So let's write that down. The domain of f of g is all real numbers except -5 and -14 thirds. Okay? So if we want to write the answer in interval notation, we write it as follows. -infinity to -5, union -5 to -14 thirds, union -14 thirds to infinity. And there's the domain of the composite function.